Nanotech and smart materials are trending. Scientists are excited about novel materials they've developed. These materials push the limits of physics without truly breaking them, as we're confined by those laws. Some have truly shifted our understanding of material physics and properties. Number 10. Gallium. Gallium is one of only 4 metals which are present as liquids at temperatures near room temperature. The others are mercury, rubidium, and caesium, and their most familiar use is in thermometers. Gallium is a beautiful metal. It's soft and silvery and has a melting point of just 29.8 degrees Celsius, meaning it will easily melt in your hand. It boils at 2,229 degrees Celsius, which is quite high. There's a massive gap between its melting and boiling points. When contrastingly, mercury boils at just 356.7 degrees Celsius. Unlike mercury, gallium is perfectly safe, meaning you can handle it without worry. This also means it's occasionally used as a replacement for mercury in medical thermometers. Gallium is also alloyed with other metals to create brilliantly bright mirrors. It just goes to show that even the elements of the periodic table have seemingly strange properties on their own. Number 9. Hydrophobic Materials. You may have used waterproof spray on a tent or on your shoes or boots, but then when it really buckets it down, it tends to fail pretty quickly. Creating waterproof sprays is no easy task, but it's a lucrative business. Neverwet has made the first stab at dominating this market with a super hydrophobic sprayable coating that can waterproof almost anything to a depth of a few foot. Not only can it waterproof all manner of items, it also protects them against corrosion and is functional under extreme heat or cold. Neverwet adheres to almost anything, and it's widely available for a whole host of industrial and practical applications. Another liquid problem solved with smart materials is getting those drips and drabs out of a sauce bottle. Scraping the inside of a glass bottle or container for the very last drips is frustrating and wasteful. The solution? Coat the inside of the bottle with a smart, frictionless material that allows the contents to just slide out freely. These liquids could also reduce friction in oil, water, or gas pipes to prevent clogging. The only downside is that you might end up emptying half a pot of mayo onto your dinner. Number 8. Terminator Polymer. Cut this polymer with a razor blade and it will glue itself back together in a matter of hours. Okay, so it doesn't exactly move back into form on its own. You have to push the pieces together, but still, give it a while and it'll feel like it's never been cut. Dubbed the Terminator Polymer, this crazy material is aptly named after the self-healing material seen in the Terminator movies. Material designers have always sought a strong, hard, and versatile material which can fix itself on its own. But before this material was created, self-healing plastics would need a stimulus in order to instigate the healing process. For example, certain plastics would repair themselves when heat is applied to them. Contrastingly, this plastic self-heals at room temperature and does so spontaneously with 97% efficiency, meaning 97% of severed bonds will actually repair. This is achievable through the use of aromatic disulfides, which react and bond at normal temperatures. Number 7. Smart, bendable wood. Wood will always be a premier building material due to its beautiful aesthetic qualities and versatility. Generally, wood is rigid, but now bendable wood allows us to flex wooden structures into spaces to create stunning interiors, which are durable and possess extraordinary sound absorption properties. Ducta is one such company pioneering bendable wood, which possesses strength with amazing flexibility. Because of Ducta's density combined with its layered form, it's an awesome heat and sound insulator. This wood is manufactured from either particulated wood blends that are mixed with flexible glues or from carefully adhering flexible wood sheets in patterns which allow for flexibility. Number 6. Vantablack. Have you ever considered how some blacks look much darker than others? One of the darkest places on Earth might be inside a deep cave, but now we can view super dark blacks above the Earth's surface. The blackness of a color is determined by how much light it absorbs, and thus how little reflects back into our eye. The more light absorbed by a colored surface, the darker it will be. Even very deep blacks reflect some light. Though, and it's theorized that a black hole is one of the only objects in the universe that lacks any light at all. Obviously, the darkness of a black hole isn't readily observable, but Vantablack gets pretty close. Vantablack is a black so dark that it looks like how you'd imagine a black hole would look. There is no reflection, no color, just nothing but darkness. Even on computer screens it looks rather strange, much darker than the blacks we're used to seeing. This black is made from very densely packed carbon nanotubes, and it absorbs a massive 96% of all visible light. The artist, Anish Kapoor, famously seized exclusive rights to the original Vantablack color, but the recently created Vantablack 2.0 is even darker. Number 5. Line X. Smart materials in cans, it's a big theme in the 21st century, and Line X's spray paint offers a method of making virtually any object far more durable by simply coating it in a spray. Once sprayed, Line X forms long polymers which bind to the surface of the object, encasing it in a solid plastic. Line X is used to prevent the splintering of plastic car parts, but can also be sprayed on other surfaces to help them absorb shock and prevent shattering and splintering. Line X is used on the walls of the Pentagon to reduce the chance of shrapnel penetrating the building in the event of an attack. Line X's ability to strengthen fragile objects has been demonstrated with plastic cups that can withstand a human's weight after being sprayed. Eggs coated in Line X can even withstand drops from great heights. The uses of Line X are pretty unlimited. Anything which is prone to shattering, cracking, or splintering is easily strengthened with Line X, and it's incredibly hard-wearing and weatherproof to boot. Number 4. Supercooled Rubidium. So, here's a material which really does seem to defy physics. Specifically, Newton's second law of motion. Newton's second law says a force is equal to the mass of an object multiplied by its acceleration. These forces are exhibited in the direction you expect. So, for example, when you push a door, it opens outwards in front of you. Supercooled rubidium, created by cooling rubidium to near absolute zero, reverses Newton's second law. When you exhibit a force on supercooled rubidium, it seems to actually push the opposite way. The physicists themselves were baffled. "It's very counterintuitive and weird," said John Butterworth at UCL London. Others suggest that the analogy some use to describe this effect is a bit off. While supercooled, rubidium does seem to behave like a material with negative mass. The atoms don't literally weigh less than zero. Number 3. Hydrogels. Some advanced hydrogels are mechanical metamaterials which float like liquids, meaning they can be poured into cavities. It then solidifies whilst remaining highly absorbent. The primary use of hydrogel is in medicine. Hydrogels can be inserted into wounds and then drugs can be absorbed into them. Some hydrogels are made from long-strand polymers, but the very last have been created organically from DNA. One highlighted potential use of hydrogels is to deliver drugs to areas where tumors have been removed but cancer cells remain in the surrounding tissues. Hydrogels would conform to the cavity and anti-cancer drugs could be delivered to surrounding specifically affected tissues. Number 2. Starlite. Starlite is by far the most mysterious material on this list. Firstly, it wasn't produced by any scientists, but instead by an amateur inventor named Maurice Ward, who was a forklift driver and ladies' hairdresser from Blackburn, UK. Ward claimed to have invented a remarkable material that could insulate anything from extremely high heats. In fact, some tests claim that Starlite could withstand temperatures of over 10,000 degrees Celsius. Ward essentially cooked this up in his own house and used it in his hairdressing business before realizing quite how effective it was. After mailing top chemical companies with requests to demonstrate the product, he was finally invited onto the BBC science program Tomorrow's World in the 1970s. The presenter famously blowtorched a raw egg for an amazing 5 minutes at 1,500 degrees before demonstrating that it remained completely raw inside when cracked. Ward's material finally attracted attention, and even the NASA spokesperson at the time seemingly verified the authenticity of Starlite. We have done a lot of evaluation, and we know all the tremendous possibilities that this material had. Ward had achieved something that decades of intense research could not, and his material would be incredibly useful in many industries. Rumors suggest that Starlite went black, meaning it is safeguarded by governments to prevent it from being replicated. Starlite is so resistant to heat that it could safeguard objects from nuclear blasts. The truth is, Starlite and its current status is still a bit of a mystery. Number 1. Aerogel and SF6 Gas. When aerogels were first developed in the 1960s, they were seemingly strikingly defiant of traditional material physics, with extremely low densities and extremely low thermal conductivity. They are porous materials that were nicknamed frozen smoke due to their rather ghostly appearance. Aerogel is more of a foam than a solid, but it's still capable of holding 3D shapes. Despite its remarkably low density, 150 brick-sized blocks of aerogel will only weigh as much as a gallon of water. The coolest property of aerogel is its heat-insulating properties. Experiments show how even a small sheet of aerogel can insulate something delicate like a flower from the heat of a flame. Aerogel has been employed by space agencies like NASA as a super light insulator. It can be packed into spacesuits or used as cavity insulation for spacecraft. Sulfur hexafluoride, on the other hand, has a rather contrasting characteristic of being very dense for a gas, about 5 times denser than air. It's non-toxic and inerrant, meaning it can be employed freely as a gas insulator for electronics. This also means you can safely breathe it from a balloon to observe the super low pitch of your voice created by the gas high-density. Smart materials that open new avenues for scientific understanding and practical applications and are constantly developing. There are probably many highly advanced materials in research and development right now, and many may yield fantastic benefits for humanity. Which material did you think was the coolest and more revolutionary? Let me know in the comments down below. Thanks for watching.